Today we are going to be talking about the sum or difference of cubes. Sum or difference of cubes. In this class that I'm recording this video in, I'm on page 98. But if you're in the Algebra 2 class, this will be your page 100. So don't let the pages throw you off. Just, if you're watching this, I'm assuming you need help with the sum or difference of cubes. So just worry about the topic. Don't let the pages throw you off. Okay? Alright, so for sum of cubes, alright, so you know how we learned about difference of cubes, perfect cube minus a perfect cube, right? And there's a special way that you factor a difference of cubes, or I'm sorry, difference of squares. Well, there's also another special case, two special cases that we're going to talk about today. It's a sum of cubes or a difference of cubes, okay? Perfect cube plus a perfect cube minus a perfect cube. So for sum of cubes, if you have a sum of cubes, that means you have a perfect cube. Like a cube is a perfect cube because a times a is a perfect cube. Like a perfect square is when you multiply something by itself, right? A times a makes a squared, that's a perfect square. Perfect cube is when you multiply something by itself 3 times, that makes a perfect cube. So a sum of cubes is if you have a perfect cube plus a perfect cube. So in my example, I'm putting a cubed plus b cubed. If you do have a sum of cubes, to factor it, you just follow a pattern, okay? You have to memorize this pattern. This pattern will not be given to you on the test or on the FSA or end of course exam. So you have to know the pattern. So to factor this sum of cubes, the pattern would be, you take the cubed root of the first term. So the cubed root of a cubed would be a, plus the cubed root of the second term. The cubed root of b cubed would be b. And that's what's in your first set of parentheses. And then your second set, you're going to have a trinomial, so you're going to have 2 terms there. And the second set, whatever a was, you square it. And then you subtract. Then you a times b. And then you add whatever your b was, you got to square it. And that's the pattern. The most difficult thing about it is making sure you have the right number for a and b and a squared and b squared and ab. Okay? Now, if you have a difference of cubes, the pattern's very similar. Only thing different really are some of the signs. Some of the signs are different, some of the signs are not. So for difference of cubes, difference of cubes is when you have a perfect cube minus a perfect cube. So when you go to factor it, same thing. You're just going to follow the pattern. All right? So the pattern is, you take the cube root of the first term. So in this case, that would be a. You minus the cubed root of the second term, so b. So just like above was a plus b, was a sum, the first binomial had a plus in it. This is a difference. My first binomial has a minus sign, okay? And you still take whatever a is, you square it. This time you're going to add a times b. And you're going to add b squared. So the plus b squared, that stays the same in both of them. But the other 2 signs are different. They're opposite of each other, but the plus b squared is the same. Cool beans? Alright, so let me show you an example. In our problems, some of them we're going to just factor only, and then some of them we're going to factor and solve. Okay? On your homework, you have to factor and solve. But this first example, we're just going to factor. All right, so let's get that down. So Let us factor 8x cubed plus 1. Eight x cubed plus 1. Okay, y'all may not be really familiar with your perfect cubes. And there's some of them that are going to be really important. Let's make a quick list down the side over here. Anybody know what 1 times 1 times 1 is? 1. That means 1's a perfect cube. Not cubed. Perfect cube. That means if I said, what is the cubed root of 1? And that's how you would write that. The little 3 in the radical. Usually when we're taking the square root, you don't put a number there. It's an implied 2, meaning square root. But if I have a number there, that means what did I multiply by itself 3 times to get 1? So what would the cubed root of 1 be? 1. So 1 is a common perfect cube. Anybody know what 2 times 2 times 2 is? 8. So 8 is a perfect cube. All right? So if I ask you what is the cubed root of 8, what would you tell me?
2 times 2 times 2.
But you would just say
2.
2. Because it wants to know what did you multiply by 3 times to get 8. Like when I say the square root of 4 is 2, because I'm saying what did I multiply by twice to get 4, right? The square root of 64 is 8. You wouldn't say 8 times 8. You know what I mean? Jelly bean? Okay, so 8 is a common perfect cube. Anybody know what 3 times 3 times 3 is? 27. So the cubed root of 27 is 3. How about 4 times 4 times 4? 64. 64 is a perfect square and a perfect cube. What's the square root of 64? 8. What's the cubed root of 64? 4. So those are 1, 8, 27, and 64 really common perfect cubes you want to have memorized. And another one that's pretty common is 5 times 5 times 5. 125. So the cubed root of 125 gives me 5. And let's just throw one more up in here. 10 times 10 times 10. 1,000. So 100 is a perfect square. 1,000 is a perfect cube. Notice it has 3 zeros. 1,000 is 3 zeros. Cube. 100 has 2 zeros. It's a perfect square. All right, so memorize those. 1, 8, 27, 64, 125, and 1,000. Are those the only perfect cubes in the universe? No, those are just really common ones, okay, that you need to know without a calculator. Okay, so back to my problem. Is 8x cubed a perfect cube? Yeah, and think about it. You can think about the coefficiently separate from the variable. 8's a perfect cube, right? What's its cubed root? 2. X cubed is a perfect cube. What's its cubed root? Is 1 times 1 times 1 x cubed?
No.
What would it be? Just x cubed. What times itself 3 times gives me x cubed? X, right? X times x times x is x cubed. So x cubed is a perfect cube. Its cubed root is x. Does that make sense? All right, is 1 a perfect cube? Yeah, and there's a plus sign. So we would call this a sum of cubes. Sum of cubes. And I know we just wrote the pattern above, but since we're trying to memorize this pattern, I'm going to write it every single time I do a problem. I write the pattern with it, and that helps me memorize it. So for a sum of cubes, you do a plus b. Use the same sign as in the problem. Sum, use the plus first. And then in your second set, a square, do the opposite sign, so it'll be minus a times b. And then in both sum and difference of cubes, it's always plus b squared. Right on? do not try to just figure all this stuff out in my head and plug it into the pattern and move on with my life. I figure out what all the pieces are over to the side, and then I just plug them in, and then it's factored. Okay? So, A is talking about the cubed root of the first term. So to find A, I need to take the cubed root of 8x cubed. Just think about it separately. What's the cubed root of 8? You already told me. It's 2. What's the cubed root of x cubed? X. So would you agree that 2x times 2x times 2x is 8x cubed? Yes. So wherever I just see an A in the pattern, I'll plug in a 2x. I'll do it all at the end though. You do it how you want it. This is how I do it. B is talking about the cubed root of the second term, regardless of the sign, because we're going to use whatever signs the pattern says. So don't worry about putting a negative or a positive under the radical. So what's the cubed root of 1? 1. So wherever I see a B, I'll plug in a 1. We're going to need A squared. So look to see what you found for A, not the first term, that's A cubed, okay? See what you found for A is 2x. If I square that, doesn't that mean 2x times 2x? Which is what? 4x squared. So in my pattern, when I see an A square, I will plug in a 4x square. Everybody cool so far? Am I going too fast? Too slow? Or just right? Must be just right. B squared, look to see what you have for B, and we're going to square it. So that means 1 times 1 is 1. So wherever I see a B square, I'll plug in a 1.
We heard you.
Alright, another thing you have to plug in is AB, so A times B. So whatever we have for A, which was 2x, times whatever we found for B, which is 1, multiply those together, 2x times 1 is 2x. So now I have all of the parts that I need to plug into the pattern. I'm just going to drop this down a little bit to give myself more room. So for A plus B, I'll put 2x plus 1. And then in my second parentheses, I start with A square, which is we found to be 4x squared. Then it says to subtract A times B, which is 2x. Then it says to add whatever B squared is, which we got is 1. And that's factored. It's not solved, but it's factored. If I were going to solve it, how many solutions would I have? 3. Good. And you know that because there's 3 degrees, right? How many solutions would we get from this first factor? 1, because there's 1 degree. So I'm going to get 1 solution. How many solutions would I get from the second factor? 2, because there's 2 degrees, right? Now, what you should be thinking is, but Ms. Rayleigh, this second set of parentheses, that's a quadratic. And a lot of times we can factor a quadratic, right? So this may be able to be factored further. So we should probably check it. Even if you only check it in your head, what would, in this quadratic, what is A? And we're not talking about the cubic. A's and B's from the cubic is different than the quadratic. 4. What is B? negative 2, and C is 1. So in our little bless you, T-chart, I need two numbers that bless you, multiply together to give me A times C, which is a positive 4, and then add together to give me B, which is negative 2. You think of anything? What can I multiply to get 4? Let's just think of anything I can multiply to get 4. Alright, so, bless you. 2 times 2 is 4. 2 plus 2 is 4. What if I did a negative 2 times a negative 2? That would give me 4. And when I added it would give me negative 4. So that's not going to work.
4 times 1.
Alright. 4 times 1 is 4. And 4 plus 1 is 5. And if I did the negatives, that wouldn't work either, right? Is there anything else that I can multiply together to get 4? No. So if I've exhausted all of my possibilities and nothing's going to work, then that tells me this quadratic's not factorable. Now I could still solve it, right, if it asked me to, but it didn't ask me to. But it just wanted me to factor. So as far as factoring goes, this is factored completely. Factored completely. Everybody cool with that? Now you're probably thinking, okay, if I distributed this factor times this factor, I'm supposed to end up with what I started with, 8x cubed plus 1. But how in the world, if I multiply all of those things together, would that even be possible? Are you thinking that?
It's because 2x.
You're not?
It's because 2x minus 2x.
Right, we're going to have some stuff that canceled. I'm not going to do it on this one because I kind of ran out of room, but on the next one, we only have to factor as well. And I'll check it out, and so you can see how all of those terms really do simplify into those two little terms we started with. So we're at the top of page 99. If you're in Algebra 2, you would be at the top of page 101, but we are at the top of page 99. And we are going to factor 27x cubed minus 8. 27x cubed minus 8. Okay, all right, I have two terms here. Is 27x cubed a perfect cube? Yeah. Is 8 a perfect cube? And there's a minus sign. So what kind of special case is this? Difference of cubes. Minus is difference, right? Perfect cube minus a perfect cube, that is a difference of cubes. So the only thing we have to do is factor it. So I'll follow my pattern, which I'm going to write every single time so that it's memorized. So my first set of parentheses, what do I put? A minus B. Second set, A squared, and then plus AB plus B squared. Good. Going to figure out all my parts. So A is talking about the cubed root of the first term. So to find A, we have to take the cubed root of 27x cubed. What's the cubed root of 27? 3. What's the cubed root of x cubed? X. So what's the cubed root of 27x cubed? 3x. To find B, we take the cubed root of the last term. Don't even worry about that minus sign because we're using the signs in the pattern. Okay, so don't let the minus throw you off. What's the cubed root of 8? 2. Because 2 times 2 times 2 is 8. Now I need to know what A squared is. So whatever I found for A, square it. And I just go ahead and, instead of writing 3x quantity squared, I just go ahead and write 3x times 3x. but whatever you want to do is fine as long as you get the right answer. And what is 3x times 3x? 9x squared. Good. B squared. Take what you found for B and square it to get 4. Good. It's a tough one. A times B, AB. A is 3x times B is 2. So AB will plug in 6x. Now we have all our parts. We just have to plug it into the pattern. Boom, it's factored. Okay? So what am I going to put for A minus B? 3x minus 2. And then I will write 9x squared plus 6x plus 4. 3x minus 2, that's a linear factor. The only way you can factor linear factors is if they have a GCF. Does it? No. So that's completely factored. 9x squared plus 6x plus 4, that's a quadratic. It may be able to be factored using divide and slide. If so, I would need two numbers that multiply together to give me 36 and added to get 6. We have 36 and 1, 6 and 6, 9 and 4, 18 and 2. I think that's all the factors. Is any combination going to not only multiply to get 36 but add to get 6? No. I want to say every time, but I honestly can't tell you 100% sure, so I don't want to say every time. But I feel like whenever you have a sum of cubes or a difference of cubes, that this quadratic that you always have in the second set of parentheses, I'm almost positive that that's never going to be able to be factored further. Like if you do your little T-chart thing, find two numbers that multiply together to give you AC and add to give you 6, almost positive that you'll never be able to factor that further. So at the very minimum, just do it in your head, on the second one just to make sure, but I'm almost positive. So in that case, this will be completely factored. Now let me show you how I am going to on this one distribute so you can see how when I multiply these two factors out, I will end up with just 27x cubed minus 8. So I'm going to check. And I'm going to distribute. What's 3x times 9x squared? Y'all gotta work with me on this. 27x cubed. 3x times positive 6x. Positive 18x squared. And 3x times positive 4. Plus 12x. Now let's distribute the negative 2. Negative 2 times 9x squared. Negative 18x squared. Negative 2 times positive 6x. Negative 12x, and negative 2 times positive 4. Negative 8. And somehow all of that is going to condense to 27x cubed minus 8. So what term has the highest degree here? 27x cubed is 3 degrees, right? Are there any other terms with 3 degrees? Alright, so I'm going to write that down. So obviously the next highest degree would be 2 degrees. I've got positive 18x squared and negative 18x squared. So those will turn into 0. Already took care of that one, so I'm going to exit out. Linear terms, plus 12x minus 12x, that makes 0. And the only thing I have left is the constant of negative 8. Is that what I started with? Yeah, so it did work. Amazing. Now let me show you one where, and this is what your homework is on, you got a factor, which is what we did here, and solve. Okay, factor and solve. minus 32 equals 0. Oh, I forgot to write factor and solve. Factor and solve. How many solutions are we looking for? 3 solutions. 3 degrees means 3 solutions. I see that x is cubed, so I'm thinking difference of cubes is 4x cubed a perfect cube. Is 4 a perfect cube? Nope, it's a perfect square. Right? It's not a perfect cube. Is 32 a perfect cube? No. Maybe it's the difference of 2 squares. Is that a perfect square minus a perfect square? No. What's that one question we always ask ourselves when we're factoring? Is there a GCF? Is there? Yeah. Then factor it out. What is the GCF? 4. So when I factor out the 4, and on your homework, you have like 3 problems that have a GCF. And don't come to me and go, I couldn't do these because I didn't know how. It probably has the greatest common factor in it. Take it out and then go from there. So what's 4x cubed divided by 4? X cubed. Negative 32 divided by 4? Negative, what? 8. Now what's inside parentheses? Is that a difference of cubes? Yes. So we're going to have this extra factor out here that we didn't have before. That's okay. It's just the greatest common factor. When I go to solve, if I set 4 equal to 0, is that going to give me a solution? No. Because this has 0 degrees, means 0 solutions, right? And 4 doesn't equal to 0. If that were a variable, I'd get a solution from that. But that's just a number, all right? But it's still a factor. So if I say to list the factors, you've got to include 4 as one of your factors. Right on? Right on. But inside parentheses, we have a difference of cubes. So my pattern is a minus b times a squared plus ab plus b squared. I wrote difference of cubes inside parentheses. Okay, so let me figure out my parts. Now when I'm looking at A and B for difference of cubes, don't look at 4x cubed minus 32. First of all, those aren't cubes, so it's going to be, you're going to get confused. We're not factoring that right now. We're factoring x cubed minus 8, okay? So to find A, I need the cubed root of x cubed, which is x. I'm going to kind of write this in a different way this time because I need more space since we're solving. To find B, I need the cubed root of 8, which is 2. To find A squared, take whatever you have for A, square it, and you will get x squared and then for b squared, take whatever you found for b, square it, and you will get 4. And then we need a times b, so it'd be x times 2 is 2x. Can y'all follow that? Kind of looks like a big jumbly mess. Bless you. So now I'm going to factor. I have the GCF of 4. It's a factor. I have to include it. For a minus b, that'll be x minus 2. And then in my next set of parentheses, I will put x squared plus 2x plus 4. So if I were factoring, would I be able to factor this quadratic further? I would need two numbers that multiply to get 4 and added to get 2. 2 times 2, 4 times 1. Is anything going to work? Okay, so for just the factor part, it's factored. But now I have to solve, right? And how many solutions am I looking for?
3.
3 solutions. So if I set each factor equal to 0, if I set 4 equal to 0, is that a solution?
No.
No. If I set x minus 2 equal to 0, can I solve for x?
Yes.
Yeah. I'll add 2 to both sides, and x equals 2. So that's one of my solutions. I'm a third of the way there because I need 3 solutions. And that's a real solution. So if I know if I were graphing that I would plot on my x-axis a point at positive 2, right? Because my graph crosses at all real number solutions. Now my other factor is x squared plus 2x plus 4. If I set it equal to 0, and I subtract 4 from both sides, can I get the x by itself? Can I isolate the x? No, because we have a quadratic term and a linear term. If we were missing one of those, we could solve for x, no big deal. But we have them both, so you can't just isolate the x like we could over here because we didn't have that quadratic term. Well, we already know, we know several ways to solve a quadratic. We can solve by factoring. Can we solve this one by factoring? No. We can solve using the quadratic formula. Can we do that on this one? Yeah. If it's a quadratic, you can always solve using the quadratic formula. It always works. You could solve by completing the square, because you can always do that for quadratics, and that always works if you so choose. Those are our options. So since we can't solve by factoring, which to me is my preferable choice, then I've got to do one of the other two, either quadratic formula or completing the square. Okay? So I'm choosing quadratic formula, of course. So when I look at my A, B, and C, remember I'm not looking at this A and B over here. That was for this cubic. That's a different A and B. A, B, and C for the quadratics, we know this. So just don't get them confused. So what's A? 1. It's a coefficient of my quadratic term. What's B? 2. And what is C? 4. And we'll just plug that into the quadratic formula, which y'all remember it, right?
X
You got it? Come on.
I remember.
X equals negative B plus or minus square root B squared minus 4AC all over 2A. Yeah. I'm going to make myself a little note. Saying x squared plus 2x plus 4 is not factorable. So to solve, I am using the quadratic formula. Not me. Not that creative. Again, if you want to use completing the square, if you remember how to use that, you like that method better, you can always use completing the square to solve a quadratic. Just like you can always use a quadratic formula to solve a quadratic. Factoring, you can use if it's factorable. Factor it, set the factors equal to 0, solve for x. We already tried to factor this one in our heads. It wouldn't work, so we couldn't go that route. Everybody with me? Okay, so now I'm just going to plug it in. I know I'm looking for 2 solutions. So x equals, what's opposite of b? Negative 2. Plus or minus the square root of whatever b is, square it, minus 4 times 1 times 4 all over 2a, so that'd be 2 times 1. Then I'm just going to simplify. X equals negative 2 plus or minus 2 quantity squared is 4. And then minus 4ac. Minus 4 times 1 is negative 4. Negative 4 times positive 4 is a negative 16. All over 2. X equals negative 2 plus or minus, what's 4 minus 16, y'all? Negative 12, good. All over 2. I'm looking for all of the solutions. Can I stop here and say no real solution on this part?
No.
Yeah.
If I only wanted real solutions, I could, but I want all solutions. That means real and imaginary. So I've got to simplify this because it's going to be imaginary because we have a negative under the radical, right? So I'm going to do that in green over to the side. What's the square root of a negative? Square root of negative 1. I. Imaginary number, y'all remember that? Is 12 a perfect square? No. Does it have any perfect, and we're looking at squares now, not cubes, right? Does 12 have any perfect square factors? Yeah, like what?
2.
Was 2 a perfect square?
4.
4. So if we use the square root of 4, that'd be square root of 4 times square root of 3, right? Because that makes 12. What is the square root of 4? 2. 2 times I is 2i. And then the square root of 3, it doesn't have a perfect square factor besides 1, and that doesn't help us out. So it will stay under the radical. Is there anything else I can do to simplify square root of negative 12? No. Okay, so over here, that's x equals negative 2 plus or minus. Instead of square root of negative 12, I'll write 2i square root of 3 all over 2. Can I reduce that? Can I what's negative 2 divided by 2? Negative 1. So if I can also reduce this term, then I should reduce.
What's after negative 1, negative
12. Here?
1?
Over here?
2i?
Yeah, 2i square root of 3, because we took square root of negative. Can I reduce 2i square root of 3 divided by 2? Yes. Yeah. Because it's okay, you can multiply or divide real and imaginary numbers. You can't add and subtract real and imaginary. So reducing is dividing, right? So since this 2 is outside of the radical and this 2 is outside of the radical, we can reduce that. We can divide those. So if I reduce, x equals negative 2 divided by 2 is negative 1. And then plus or minus 2i square root of 3 divided by 2 would be 1i square root of 3, or we would just put I square root of 3. And how many solutions is that? 2 solutions. Negative 1 plus I square root of 3 is one of the solutions. Negative 1 minus I square root of 3 is other solution. So we have 2 imaginary solutions there. If we were graphing, would that help us with our graph? No. But it is 2 of the solutions. And then don't forget, we had that x equals 2 from before. So did we find all of our solutions? Yes. I'm going to write them all down, but I'm kind of out of room on the left side of my page. So over here, my solutions, I had 2. Negative 1 plus I square root of 3, and negative 1 minus I square root of 3. 3 solutions. And that's it. So again, on your assignment, you have to factor and solve. Some of your problems are going to have a greatest common factor that you have to factor out first before you're going to see that it's a sum or difference of cubes. Okay? So every problem, you gotta factor it. Factoring's part of your answer. And then you have to show me all this work to how you got the solutions. If you just show me the solutions, I am not giving you credit, because I know you did not go from this to this in your head. Everybody good with this? May I have a question?